I start with 7.5 indeterminate forms and L'Hopital's rule. Here I examine the limit as x tends to a of a quotient. So I can write limit x tends to a, then this quotient. Now here in this case, both numerator and denominator tend to 0 as x tends to a. So I write 0 by 0 and I write it this way. Such a limit is called an indeterminate form of type 0 by 0. This limit is called an indeterminate form of type 0 by 0. When I use the word indeterminate form, that just means that this limit cannot be found without further examination. So you just cannot find out this limit without further exploring things. If I write this expression, limit x tends to 4, x squared minus 16 by x by 4 root x minus 8. Now in this case, earlier the way we have solved this limit is we wanted to think of it this way. Limit x tending to 4, this numerator can be written as, so in fact this is also an indeterminate form. Sorry, this one is an indeterminate form. This limit is also an indeterminate form of type 0 by 0, precisely because here I see that x squared minus 16, this f of x tends to 0 as x tends to 4, and if I take g of x to be 4 root x minus 8, even in this case I see that 4 root x minus 8 that tends to 0 as x tends to 4. So clearly this limit is an indeterminate form of type 0 by 0. But earlier the way we solved this is this. I can write the numerator as this. The denominator can be written as 4 multiplied by root x minus 2. This is equal to limit x tending to 4, and even in this case x minus 4 can be written as root x plus 2 and root x minus 2, their product. So I write x plus 4 and root x plus 2, root x minus 2. This then can be written as 4 root x minus 2. Now these two get cancelled, and that means we are left with limit x tending to 4, x plus 4, root x plus 2 divided by 4, which is nothing but 8 multiplied by 4 divided by 4, and you get the answer as 8. This is how we have understood the things till now. This is how we have tried to understand and solve the indeterminate form of the limit of type 0 by 0. However, there is a standard method for the systematic treatment of such indeterminate forms, and that standard method is what we call L'Hopital's rule. So if I have to define the L'Hopital's rule, it's nothing but a standard method for systematic treatment of indeterminate forms. And this standard method is called the L'Hopital's rule. All right, to understand this, let's start with an indeterminate form. Limit extending to a f of x by g of x, and here both the numerator and the denominator tend to 0 as x tends to a, so I write it like this. Now here suppose both f and g are differentiable, so I write f and g are differentiable. Also in this case f of a is equal to g of a is equal to 0. So we know that this is the case. We start with an indeterminate form of this type. Here f and g are differentiable, and I know that f of a is equal to g of a is equal to 0. Now in this case, when I have x not equal to 0 and g of x not equal to g of a, when this is the case, then I can easily show this. So I start with f of x by g of x, and I keep this information in mind, this one, that f and g are differentiable. Also f of a is equal to g of a is equal to 0. If I know this, then when x is not equal to 0 and g of x is not equal to g of a, I get this. I can write f of x by g of x this way, in the sense that I can actually divide both numerator and denominator by x minus a. Now clearly x minus a is not equal to 0 because x is not equal to a. I should have written x not equal to a here. So I divide both numerator and denominator by x minus a. Also I know that both f of a and g of a are equal to 0. That means I can write f of x minus f of a divided by x minus a, the whole of this divided by g of x minus g of a divided by x minus a. Now in this case, I was earlier concerned about limit extending to a f of x by g of x. And that just means I'm concerned with the limit as x tends to a of this expression. And if we look at the right hand side, that is f of x minus f of a by x minus a, the whole of it divided by g of x minus g of a by x minus a. If we look at this expression and we think of its limit as x tends to a, I know that both the numerator and the denominator tend to f prime a and g prime a respectively. So the numerator tends to f prime a as x tends to a, and the denominator tends to g prime a as x tends to a. So this then can be written as f prime a divided by g prime a. And now provided that g prime a is not equal to 0, this limit is actually equal to this one. And so this is nothing but our L'Hopital's rule. Again, I should write provided g prime a is not equal to 0. So now I can write the simple version of the L'Hopital's rule, that is this. Again, in this case, if f and g are differentiable, so we need to keep this in mind that f and g have to be differentiable at a with, if this is the case, with f of a equal to g of a equal to 0 and g prime a not equal to 0, then I can write limit x tending to a f of x by g of x to be equal to f prime a divided by g prime a. And this is nothing but my L'Hopital's rule in its simple version. Basically, according to the L'Hopital's rule, I can find the limit of an indeterminate form of type 0 by 0 by differentiating the numerator and the denominator separately. So this is something we need to keep in mind. Next, we take up some questions. So we find the earlier thing, and now I use L'Hopital's rule. So clearly I know this is an indeterminate form of type 0 by 0, so I can write it this way. You just have to check what happens to the numerator as x tends to a, here x tends to 4, and what happens to the denominator as x tends to a, and here x tends to 4. So here in this case, just suppose that your f of x is nothing but x squared minus 16, your g of x is nothing but 4 root x minus 8. Also, you can see here, just to check whether you can actually apply the L'Hopital's rule, you can see that f of 4 is equal to 0 and g of 4 is also equal to 0. Then obviously you can apply the L'Hopital's rule. For this, you calculate f prime x, which you know is 2x. You can calculate g prime x, which is so it's 2 divided by root x. And now the next step is to calculate f prime 4, which is nothing but 8, and then to calculate g prime 4, which is nothing but 1. Now you just have to apply the L'Hopital's rule directly. So here I write this is equal to f prime 4 divided by g prime 4, which is nothing but 8 by 1, and that is 8. So now the calculation becomes much easier with the help of the L'Hopital's rule. Let's take up one more question. Limit x tending to 7 cube root x plus 1 minus root x minus 3. The whole of this divided by x minus 7. Again, this is an indeterminate form of type 0 by 0. How do you check it? You think of what happens to the numerator as x tends to a and what happens to the denominator as x tends to a. You here see that both of them tend to 0 as x tends to a. So clearly this is an indeterminate form of type 0 by 0. So you write it this way. The next thing to write is limit x tending to 7, and now you differentiate the numerator. I can write 1 by 3 x plus 1 minus 2 by 3 raised to the power minus 2 by 3 minus 1 by 2 x minus 3 raised to the power minus 1 by 2. The whole of this divided by 1. Now you can think of this as 1 by 3 8 raised to the power minus 2 by 3 minus 1 by 2, 4 raised to the power minus 1 by 2. This turns out to be, in this case, 1 by 12 minus 1 by 4, and that is nothing but minus 1 by 6. So the answer in this case is minus 1 by 6. Here I have to mention one point before I take up one more question. Suppose I start with this again. In this case, suppose I have a 0 by 0 form, as in we have an indeterminate form of type 0 by 0 here. But when I calculate f prime a and g prime a, and I think of f prime a divided by g prime a, this is also of the type 0 by 0. So what I'm trying to say is, I have an indeterminate form of type 0 by 0 here. And then when I apply the L'Hopital's rule and I get this limit to be equal to f prime a by g prime a, that is also of the type 0 by 0. Now, because g prime a is 0, we have to note that we can't actually use this argument, because the argument in fact breaks down. This is what is required here. And here, if f prime a and g prime a, both of them are equal to 0, then we can't actually apply this argument. So the argument breaks down. In that case, what do? We in fact differentiate once more both the numerator and the denominator separately. So the point is, even after that, if I obtain an expression of the type 0 by 0, I keep on differentiating the numerator and the denominator. I keep on doing that repeatedly until I get the limit, until the limit is determined. So just to understand this, I take up one last question before we take up the extensions. So let's take up this question. Limit x tending to 2, x raised to the power 4 minus 4x cubed plus 5x squared minus 4x plus 4. The whole of this divided by x cubed minus 2x squared minus 4x plus 8. Clearly, you can see here that both the numerator and the denominator tend to 0 as x tends to 2. So this is an indeterminate form of type 0 by 0. So what's the next step? You apply the L'Hopital's rule and you see that you get this. 4x cubed minus 12x squared plus 10x minus 4 divided by 3x squared minus 4x minus 4. Now you see that even this is an indeterminate form of type 0 by 0. Even in this case, both the numerator and the denominator tend to 0 as x tends to 2. So I can write this as this. Now this is equal to limit x tending to 2. Basically, I'm applying the L'Hopital's rule twice now. So that is 12x squared minus 24x plus 10 divided by 6x minus 4. Now this is not an indeterminate form of type 0 by 0. So here I see that I can actually get the limit here. I mean, the limit is determined now, and that it is equal to 5 by 4. So this is the case where you apply the L'Hopital's rule twice. I have to mention one thing here, and this is just a warning, that we never differentiate f by g as a fraction. We are computing f prime by g prime when we are applying the L'Hopital's rule. So let me give it a warning here. Do not differentiate f by g as a fraction. This is important here, that we do not ever differentiate f by g as a fraction. We compute f prime by g prime instead. So this is something we need to take note of. Now what I do is, whatever L'Hopital's rule, whatever version of the L'Hopital's rule we have considered so far, we are actually going to see that the requirements on f and g are actually weaker than what have been shown here. So when I talk about the requirements, we need to actually think of this expression. Let me get back to where I was. Yes, here I have, if f and g are differentiable at a, with f of a equal to g of a equal to 0 and g prime a not equal to 0, then limit extending to a of f of x by g of x is equal to f prime a divided by g prime a. So this is my L'Hopital's rule in its simple version. The point that I'm trying to make here is that f and g need not even be differentiable at x is equal to a. So the requirements on f and g are weaker than what I have shown here. So let's just take the general form of the L'Hopital's rule. Suppose that, so we are not going to impose those restrictions on f and g now. In fact, those restrictions that we impose now are much weaker than what we have shown earlier. So suppose that f and g are differentiable in an interval alpha beta around a. We are not saying that they have to be differentiable at x is equal to a. In fact, we write except possibly at a. So now we have weakened the requirement. Suppose that f and g are differentiable in an interval alpha beta around a. We take a open interval around a, except possibly at a. Suppose that both f prime, not f prime, it's f of x. Both f of x and g of x tend to zero as x tends to a. This is another point. Now if g prime x is not equal to 0 for all x not equal to a in this interval, and if limit x tending to a f prime x divided by g prime x is equal to L, then I can write this. Limit x tending to a f of x by g of x is equal to limit x tending to a, f prime x by g prime x, and this is equal to L. Now keep this in mind that my L can be finite, it can be infinity, or it can also be minus infinity. Let me repeat this again. What I'm now trying to understand is that the requirements on f and g that I have talked about till now, those requirements are in fact weaker than what we have shown earlier, in the sense that f and g need not even be differentiable at x is equal to a, because that's exactly what we have shown earlier. We thought of this being equal to f prime a divided by g prime a. That's not needed. So we suppose here that f and g are differentiable in an interval, in an open interval around a, except possibly at a. And now I suppose also that both f of x and g of x tend to 0 as x tends to a. If g prime x is not equal to 0, for all x not equal to a in that interval alpha beta, because g prime x should not be equal to 0 for all x not equal to 0, for all x not equal to a, because we need this limit to exist, this one. So if g prime x not equal to 0 for all x not equal to a in this interval, and if this expression is this, if limit x tending to a f prime x by g prime x is equal to L, then I can write this. And here, please keep this in mind that L can be finite, L can be infinity, or L can be minus infinity.